Let's continue with our discussion of the indefinite integral by computing some more examples together. Let's review very quickly the power rule for integrals, or anti-power rule. To find an antiderivative of x to the n, you increase the power by 1, divide by the new power, plus any real number. The antiderivative of e to the x is e to the x plus a real number. And the antiderivative of x to the minus 1 power, that is 1 over x, is the natural log of the absolute value of x plus any real number. Let's go on with our examples now that we've reviewed that. Let's pick up where we left off with our examples with number 4. Now, as I write these first couple, I don't expect you to write them this way in your notes, but it helps to see it done this way at least once. Remember that the antiderivative of a sum is the sum of the antiderivatives, so we will rewrite this 4 times the integral of x cubed dx plus 2 times the integral of x dx minus the integral of 1 times dx. And that will give us, let's see here, let's follow the power rule for integrals. We'll increase x cubed, the power by 1 to 4, and divide by the new exponent, plus 2, and we'll increase the exponent of x by 1 from 1 to 2, and divide by the new exponent, minus, remember, it says x to the 0, so we'll increase the power by 1. 0 plus 1 is 1, and divide by the new exponent. And we can simplify this expression a little bit. 4 divided by 4 is 1. 2 divided by 2 is 1. 1 divided by 1 is 1, plus c, and we have our answer. Let's continue in this vein. We have a sum of 2, so the antiderivative of the expression 2e to the x plus 3 over x would be 2 times the antiderivative of e to the x dx plus 3 times the antiderivative of 1 over x dx. We know each of these. The antiderivative of e to the x is e to the x plus a constant, which we'll leave to the end, plus 3 times the natural log of the absolute value of x plus c. When we're integrating more difficult expressions, it helps to always rewrite them using rational exponents. So with the integrand 4 divided by x cubed, we'll rewrite that as 4 times x to the minus 3, or 4 times the antiderivative of x to the minus 3. We'll use the power rule for integrals. We'll raise the power by 1. Minus 3 plus 1 is negative 2, divided by the new exponent, negative 2, plus any real number, c. 4 divided by negative 2 is negative 2, x to the negative 2, plus c. We could rewrite this without using negative exponents, like this. Just a few more examples, and then you can try one. Again, when we see an expression like this, what we want to do is rewrite it using rational exponents. Let's do a little better. Let's see. We're squaring and the cube root, so this is an exponent 2/3 du. So we'll apply the power rule. We will add 1. 2/3 plus 1 would be 2/3 plus 3/3. That's 5/3. Divided by the new exponent, 5/3, plus c. Now remember, to divide by a fraction, we're going to have to invert and multiply. And 5 times 3/5 would be just 3. U to the 5/3 plus c. And we have our antiderivative, family of antiderivatives. Whenever we see expressions getting more and more complex, what we want to do is reach back into our algebra skills and simplify these expressions before we try to compute their antiderivatives. Let's do that here. Remember that an expression like x cubed minus 3 divided by something was just x cubed divided by x squared minus 3 divided by x squared. We'll put parens around it. And now we can simplify this a little bit. X cubed divided by x squared is just x. And if we write 3 divided by x squared using rational exponents, we have a negative 2. Let's go ahead and do this the way. So we would add these. We have a 1 power here, so we would increase the power by 1. 1 plus 1 is 2, and divide by the new exponent. Minus 3 times. We would increase the power of x to the minus 2 by 1. Minus 2 plus 1 is negative 1, and divide by the new exponent, plus c. So it looks like what we have here is we have 1 half x squared, minus a minus is plus, 3 x to the negative 1, plus c. Still more practice using our rational exponents. Let's see here. The cube root would be x to the 1/3, but it's in the denominator. So 2x to the minus 1/3 plus 6x square root is 1/2 as an exponent, rational exponent, like so. So we've just done a little algebra. And now we're ready to take our calculus step. We're going to add 1 to the exponent. Minus 1/3 plus 1 is minus 1/3 plus 3/3, so that's 2/3, divided by the new exponent, plus 6, 1/2. 1/2 plus 1 is 1/2 plus 2/2, that's 3/2. We'll divide by the new exponent, plus c. Okay, so to divide by a fraction, we invert and multiply. To divide by a fraction, we invert and multiply. Finally, another algebra step, we simplify. 2 divided by 2 is 1, so we have 3 x to the 2/3. 6 divided by 3 is 2, times 2 is 4, x to the 3/2, plus c, our answer. If we need to integrate a product, as in number 10, integrating sums is so much easier than integrating products, as we'll find in the next section. So what we'd like to do is rewrite this as a sum, so we'll expand it using our algebra. We'll distribute x times x squared is x cubed, plus x times 2 is 2x. Now we have it written as a sum. We'll increase x cubed, then we'll increase the power by 1. 3 plus 1 is 4, divided by the new exponent, plus 2 times x to the 1 power. 1 plus 1 is 2, divided by the new exponent, plus c. So what do we get? We get x to the 4th divided. So what do we get? We simplify a little bit. X to the 4th divided by 4, we can't. 2 divided by 2 is 1, plus x squared, plus c. And we have our solution, our family of antiderivatives for each of these problems. Now I'd like for you to try one. Find the indefinite integral of the product of x squared minus 2 and the quantity x plus 3. Find all possible antiderivatives of this expression. I'll show you your answers in a moment. All right, so we have 5 of them here. Is it the first expression, which is the quantity x cubed divided by 3 minus 2x, times the quantity x squared divided by 2 plus 3x, all of this plus an arbitrary number c? Or is it the expression x to the 4th divided by 4 plus x cubed minus x squared minus 6x plus c? Is it the expression x to the 4th plus x cubed minus x squared minus 6x plus c, which doesn't differ from the one above it by very much? Or yet another variant, x to the fourth divided by 4 plus x cubed plus x squared plus 6x plus c? Or is it none of these? You decide. Thank you.